I'm really excited to be here, and thank you for coming out, even though it looks like it's still snowing pretty hard there. So when people talk about data-driven design, usually in industry, what that means is A/B testing. Usually you have your current version of a design and you're trying to optimize it, so you create another version, you deploy both, you send a small percentage of your users to the new version, and you see if the new version converts users in a more statistically significant way, and if it does, then you adopt the new design and make that kind of your current design. So this is how A/B testing works in general. But I actually think my research agenda for the last 10 years has been looking at A/B testing is one way to, one data-driven approach to tie design choices to outcomes. But can we come up with other ways? So, what are other data-driven techniques that can be used to tie design decisions to desired outcomes? And it's actually a pretty hard problem, and that's really why you've only seen A/B testing as kind of like the major example used in industry as a way to do this. But hopefully I can convince you in this talk that there may be some other promising approaches. First, I'm going to talk about an approach that I actually started when I was a PhD student. So a lot of my dissertation work was around this idea of design mining. And it was simply starting with this idea that, hey, there is already all of this existing data out there. Websites are actually examples of design. Mobile apps are examples of design. If you look at the internet, right, there are lots of repositories of designs out there for 3D models, for fonts, for videos, for code. So you can kind of start thinking about how can we use the machine learning and data mining techniques that have been used to understand and analyze information. Like, how can you use those same techniques to scaffolding the design process? That really was what motivated my dissertation work. I decided to look at websites, the domain of websites, and really see how we could change the design process there by leveraging existing designs. And so my dissertation work focused on how do you actually mine design from existing sites. So one of the, I would say, research contributions here was to actually figure out what are all the elements of design that we want to capture on a website. Well, there's actually the HTML itself. There's the document object model, which is what the browser layout engine creates to actually render the website. So that actually is a structured representation of the design. You also have the resources like the images and the style sheets. You also have the screenshot itself, the pixels. And then you can kind of combine these raw streams to get a visual segmentation of the design. So you can kind of start saying, I understand that this part at the top is a navigation bar. This element here represents a featured item, and so forth. So you can actually start using these visual segmentations to derive higher level features. And when you can derive these higher level features, you can start using machine learning techniques to make, for example, web design searchable. So one of the first things we did was we built a search engine for design where you could actually search by design features. So you could say, show me, coffee websites with large image backgrounds, and you can kind of see, you can also do some analytics over this. So this was like the common color palette for this query result. You could also do like element level query. So you could say, I want to understand where on a mobile site you see sign-up forms. So that was kind of another type of query you could run. We were crawling pages in different form factors, so it was useful for understanding how the design of desktop designs were different from, for example, mobile design. And so we presented this work at CHI. We actually got a lot of designers after we gave the talk just asking for this tool. And given the very positive response, I guess, that we got, we decided to actually see if we could productize this initial idea of kind of giving people these new types of data-driven design tools to actually make better informed decisions about website design. So we founded a company. It was called Apropos, and you might notice I'm using the past tense. So we raised $2 million, a little over $2 million from Andreessen Horowitz and NEA, but then we proceeded in the next 3 years to lose all of that money. But I can kind of tell you what we learned. And so I think the most important lesson that we learned was that, yes, design examples are useful, but what people really want to know is how does this example perform? Like, if you notice patterns in this data, you know that it's popular, but you don't know if it's actually good. And so that was like the critical piece we were kind of missing. And so actually the last product or tool that we got to try out before we closed the company, I think was the most promising one. And that was actually an analytics dashboard where we could actually connect design choices to key performance metrics about websites that we were actually purchasing from a third party. So you could actually buy information about things like the bounce rate of a website, the time a user spends on the site, the number of pages a user visits, and so forth. So you can buy these third-party metrics, and if you can buy them, you can start correlating them with kind of the design features that we were able to identify to say, well, if you actually are creating a software website, you might actually want to have 3 call to action buttons, one at the top, one in the middle of the page, and one at the bottom, things like that. It turns out, though, that while this was promising, I would say that this also isn't what people will pay money for, because at the end of the day, the metric that people cared a lot about was conversion rate. And so it's really about, like, will people sign up for my web page? Will they buy my product? And all of that data, that analytics, you can't buy. That lives within each company, right? And so this actually motivated a lot of the research that I work on today at U of I, which is how can we open source this analytics data? Before I talk about exactly kind of what we've been doing in this vein, I think I just want to go back a little bit to A/B testing itself. So, A/B testing is really useful, but getting statistical significance is pretty hard. And the reason it's hard is because usually, most companies don't have large user bases where they can sacrifice a percentage of their, user base to try out a new version of the website or app. They also don't have the engineering resources, right? So if you want to A/B test something, you have to build out every single version that you want to test. So really these techniques are useful for big companies, and even when you see a small percent in uplift, for a big company, that's real money, right? Like a 0.4% uplift is $50 million for a big company. But what I really think I saw when I was at the startup was there's a lot of other companies out there that are not the Amazons or the Googles or the Spotifys, and for them, A/B testing is really not a great solution. Imagine that you're a startup and you want to figure out if you should be doing your design differently, right? It's really hard because you really don't have any users at that point. So kind of the insight was how can we use the data that lives within these other companies and actually collect that data and make it possible for the smaller companies to leverage it. So that was kind of the motivation here. And then just to be very explicit about what are preferred outcomes or design desired outcomes in the space we were dealing with. This is for digital design, I would say, these preferred outcomes. And I actually focus more on, let's say, mobile app design now. So this could be applied to website design, but it's also the same set of outcomes for mobile design or other types of digital design. So people care about higher completion rate. For a task, they care about lower completion time. So they want people to do the task quickly on their site. They want fewer usability issues. You actually want people to do the task on the app without running into problems. And you want to also think about how do you make your apps and designs more accessible to everyone. So I want to introduce you to kind of a solution point in this space that we built called Zipped. And it stands for Zero Integration Performance Testing. And this is a solution for open sourcing analytics for Android apps. So we're talking just about Android apps. And the way Zipped works is that designers can define tests over any Android app. So this can be anything in the Play Store, any app you can find. So you first choose a set of apps. You then define a user task. So you can say, log the last meal you ate on these apps. And then you can also give a list of feedback questions that are, let's say, more qualitative, or you're just trying to collect some demographic information. And what Zipped will do is it'll take this specification and it will crowdsource this test. And I'll talk about how it actually does this in a second, but the idea is it'll crowdsource this test. It'll collect user interaction traces from hundreds of users out there. And then what it can do automatically is it'll be able to give you kind of these analytics over this data. So it'll kind of give you, let's say, visualizations, aggregate performance metrics, and kind of aggregate feedback. And I'll step you through all of these parts in a second. The thing that makes this possible is actually an interaction mining system that we built. And this system that we call Erica allows you to mine interaction traces as Android apps are being used. And it requires no modification to an app's source code or binary. So this is how we are able to mine interaction on apps you personally didn't build yourself. And so the way it works is we actually have the apps running in a mobile farm back at UIUC, and people are actually interacting with screens that are then being sent through a web app. And as people interact with these screens, we're basically recording all of their interaction and gestures, as well as actually collecting all of the design data back on the phones themselves. So it's kind of like the website guys example that I showed you earlier. We were collecting all of this pixel data and structured data. We're basically doing the same thing with apps now. And so here are all the different types of data that we're collecting. We're collecting the user interaction, so we know where people tapped on the screen or if they swiped and things like that. We're capturing the screenshot, the pixels that they interacted with, and we're also getting the Android view hierarchy. So that's kind of like the DOM of Android apps. It gives you the structured representation of all of the UI elements. So what happens is, as a user then interacts with an app, we're getting back a user interaction trace, so we know exactly how the user went through the app, what they did to go from one screen to the next screen. We're also collecting the screenshots at a rate fast enough that you can also do things like video playback. So these are actually video playback from the apps that we've been collecting, just to give you kind of a feel for what the data looks like. The other consideration when we built this tool is we actually want to minimize the amount of personally identifying information that we're actually capturing from the crowd workers, right? We don't want to get their personal details like their name and their phone number and things like that. So we use a sock puppeting type approach where we give them basically fake accounts that they can use to enter in things to register for an app or log into an app. We even had to do some instrumentation so that they would get the confirmation codes from like SMS texts. So there were few hairy details in terms of actually building the system, but we basically were able to take care of those details. So now let's actually talk about how an experiment would actually work on this platform. So again, as I said, a designer specifies a task over an app or multiple apps. So for example, let's consider this task, which is use this calorie tracker app and basically add 1 chocolate chip cookie to your food log for that day. And so here are some feedback questions, and let's just say that the user wanted more than 20 traces for this experiment. So what we give the user then after, let's say, the experiment ran, is we give them back a dashboard. And this dashboard gives you aggregate performance metrics. So it tells you, what was the average time taken for this task, what was the average number of interactions the users did, what was the completion rate. And it turns out for this task, there was 100% completion rate of the task, and we collected 24 user traces. We also collect the user feedback, so things like, have you used an Android device? Could you complete the task? So this is like a self-report way of collecting whether or not they thought they could complete the task. Similarly, how easy or hard did they think the task was? But I think the most useful screen actually is this visualization, this flow visualization that we give the users. And let me kind of break this down for you. So you can kind of see, this is supposed to represent all the ways that people kind of went through the app to complete the task. And the flow that you kind of see in the dark gray, that's what I'll call the designer's golden trace. So this is how the designer intended someone to complete the task. And so anything that's kind of deviating from that dark gray might be a potential usability problem, or it might indicate to you some inefficiency in how you designed your flow. So for example, the completion rate here was 100%, but you will see that there was a screen that a lot of users ran into that said there was a problem. And so you might wonder, why are people encountering this screen? And this basically says that 5 of the 24 users encountered this screen. So this dashboard basically allows you to do a deeper dive and then look at the entire trace itself to kind of get more context and figure out what was going on. In this case, it turns out that in this particular app, you had to indicate the units of what you were recording, and it wasn't very clear that you had to do it. So a lot of people were trying to save the fact that they ate this chocolate chip cookie, but they hadn't provided the units of a chocolate chip cookie. So basically, this indicates that there is a slight usability issue here that a designer might need to address. So this is kind of an example of how Zipped can be used to understand design performance and find a usability problem in an app that you personally didn't design yourself. Let me actually give you a few more case studies just to illustrate a few more examples. So one thing we did was we did these comparative studies across apps where we basically took two similar apps and we asked people to basically do the same task on both apps. So here we compared YouTube Music to Spotify Music, and the task was to add 2 songs to a new playlist that you create. This is what the completion rate for those tasks look like. And so you can notice it seems like there's a difference between the completion rate for YouTube Music and for Spotify. And we did a deeper dive based on the qualitative feedback to kind of understand what was going on. Turns out that on YouTube Music, and the last time I checked like a month ago, they hadn't fixed this yet. It turns out that you can't create an empty container playlist and add songs to it. The only way to create a new playlist is to actually try to add a song to a playlist, and at that point, you have the option of creating a new playlist. I see some nodding heads, so maybe you guys have personally experienced this before. It's funny because I actually told the designer in the YouTube team, and they knew about this problem, so I'm actually surprised that they haven't fixed it yet. But I mean, I guess it's a problem you run into once, and then you kind of learn that how to work around it. But for a lot of users, this was actually confusing. Similarly, we compared retail interactions. So we compared the Macy's app to the Best Buy app, and the task we asked people to do on these apps was to find the address of the store closest to a particular zip code. And so what I'm showing you here is the golden trace for that interaction in the Macy's app. And so it involves clicking on the hamburger icon, and then you get this fly out menu navigation, and basically takes you 6 interactions to complete this task. And the Best Buy app, there's actually 2 ways you can do this task. There's a tab navigation way, and then there's also kind of like the search way you can do it. And it only involves, the shortest path only involves like 3 interactions. And so it was interesting. I mean, a priori, given that this was fewer interactions and it was tab navigation, we thought that Best Buy would actually perform better. But interestingly, more people were able to complete the Macy's app. And it was interesting because the flow visualizations basically indicate that most people know to click on that hamburger icon menu. And so, 5 years ago, or even maybe 6 years ago, when I was working on stuff, like designers always told me, don't use that hamburger icon. That's a bad design, that's a bad pattern because you're really hiding all this information away. But it turns out now people are so trained to know to click on it, it's actually the best way to get someone to figure out how to do something on your app. So, it's just really interesting how, as more people get used to a design pattern, it can actually, the usability of that pattern can change over time. We also saw that people self-reported that doing this task on Best Buy, was more difficult to them. So I think it's useful to have these different, quantitative and qualitative streams to understand what's exactly happening as people use these apps. So at a high level, the implications, I think, of Zipped are you can actually bring testing earlier into the design process because you're actually leveraging existing designs, right? I said if you do A/B testing, you normally have to go out and build out all those variations. Here, you can leverage existing apps. If you're a small company, you don't have to start building anything. You can go and say, I want to use and test apps that are already out there where I know these companies are doing well, so maybe their design patterns are good too. Like I can actually measure their performance. The other thing that you can do at scale is you can do comparative design testing. So the only way right now to compare apps, let's say, is through a service like usertesting.com, where basically they do screen recordings of people using apps. The problem there is actually it costs about $50 per user to do this, because all of the annotation and the aggregation has to be done manually. Since we're collecting kind of the structured data, we can actually do the aggregation kind of for free in our case. Like, we can produce those visualizations basically for free. So for us, the cost is more around 50 cents a user, which is kind of the cost of getting a crowd worker to actually do the task on the app. And then the final thing I'll say is that you're able to combine these quantitative and qualitative streams of feedback. So you can, you're not just identifying the problems, you're actually trying to understand why the problems are happening and how you might actually fix them. This process is, so I want to show you this as an example of a way that's not A/B testing, right, to tie design choices to desired outcomes. But the thing I would say that it's still missing is this notion of design semantics. And what I mean by that is that you want really these higher level abstractions to represent design. So here we were just comparing like an app and how something was done on one app, right? And what we really want to do is we want to go from where we are now to a world in which we can actually extract patterns from lots of apps and say which patterns perform the best. So what we want to say is, this way of composing a login flow actually performs the best. So the piece we're actually missing there is the part where we can actually identify a portion of a flow or a screen itself as being part of a login interaction. So that's what I mean by design semantics, actually identifying these higher level abstractions that kind of allow you to aggregate data across apps. To actually do this, what we did was we wanted to basically train machine learning models to predict when different, basically predicts design semantics for apps. And when we talk about design semantics for apps, there's actually kind of different levels of granularity of the semantics. So what we did was we actually created a big repository of just app designs. It's called RICO, and actually it's the largest publicly available design database of mobile apps, so you can actually download this data and use it yourself for your applications. And what we did was we collected interaction traces for around 10,000 Android apps, which really meant it was around 72,000 unique UI screens and about 3 million UI elements. It costs a bit of money. It's about $2 per trace, but luckily this project is funded by Google, so we were able to collect this data. What we did after collecting that data is we chose to start focusing on element level semantics, and I'll explain why in a bit. But basically we coded 73,000 potential icons in this data set, because really if you're trying to understand semantics or actions that people can take on apps, like that's coded a lot in the icons. It's also coded in text buttons. So we were really, we really wanted to understand what are those common actions that are shared across apps. And so we found things like some actions are text only, so things like login, subscribe, activate, like usually you only see that in a text format. Some times you get icons for concepts, and you you start seeing these icon synonyms. So these are icons where they basically signify the same UX concept. And then you also get icon polysemes, by which I mean, depending on the context, they can mean different things. So I'm sure everyone has seen that a star icon can be used to rate as well as to favorite something. Similarly, the circle, the arrow circular icon that you can see here can sometimes mean sync. It can also mean refresh. Also, if you have questions, feel free to interrupt me. So we created this UX lexicon, and then what we did was we actually trained a code and vision-based approach for automatically identifying 25 UI component categories. So those include text buttons and icons, 197 text button concepts, and 99 icon classes. So what we were able to do with this approach is, if you gave us a screenshot as well as the Android view hierarchy for that screen, we could produce the semantified version of the screen. So that's what the output looks like of this approach. The trickiest bit was actually the icon identification, because for everything else you can basically rely on heuristics based on the code itself. Like if you wanted to identify a map view, you can basically do that with high accuracy just by examining the view hierarchy. But for icons, it's tricky because they're very hard to differentiate from just regular image. So we basically can kind of say we had a rough heuristic for identifying potential icons, which is they're kind of small, they're square. But really, you don't get a very high accuracy rate if you just use that. And you don't also know what class of icon it represents. So we actually trained a convolutional neural net to differentiate between 99 icon classes. And what it does also is it also uses anomaly detection, so we can differentiate between icons and just other things that are not icons. But basically, once we trained it, you could input a small squarish image from an app, and it would basically tag it as one of the 99 classes, or it would call it an anomaly. And just to give you a feel for what these results look like, this is what they look like. I just like looking at this data because it kind of shows you for each class kind of the amount of variation there is for an icon class. So, I mean, icons are kind of beautiful things because even though you can design an icon slightly differently, they're still like similar, right? Because that's how people know what they mean. So they can't be too different. And so this is why a neural net approach actually works really well. So now we have element level semantics, right? And I said we started with element level semantics because that's actually a great way to bootstrap higher level semantics. So what you can do is you can take, for example, the semantified versions of the screenshots, and now you can start saying, can we actually learn a semantic space for screens? So we actually use the semantified versions of the screenshots to train a deep autoencoder. Basically, a deep autoencoder is a technique where you feed in an image and you're basically trying to do a dimensionality reduction, and then you're trying to blow it back up and reconstruct that image. And usually what you do is you only use the first part of it, the encoder part, in your application. So once we train this deep autoencoder, we basically use the encoder part to and not the decoder part, to do nearest neighbor queries to show that actually in screen space now we can get at things that are semantically similar. So these screens that are the results of this query are all from different apps. So they're not like the same screen from the same app. So you can kind of see, like, if you have like a login screen or a welcome screen, you get other welcome screens back in this space. If you have like a newsy screen, you get other like featured item, like articles below screens back. So that's the idea. So that's how elements can help you, element level semantics can help you bootstrap screen level semantics. And then what I wanted to show you is actually it also helps you do flow level semantics, because if you remember, we actually have interaction data. So that was one stream of data that I haven't talked about yet. But if someone clicks on a search icon, that probably signifies that they're going to begin a search flow. And so that's kind of our heuristic right now for detecting flow semantics. And so we actually have released this other platform called O, where we're trying to use both our classifiers as well as some human curation to basically identify flows over all of this app data we've collected. Again, I really want to make a plug for go use Rico, because I think there's a lot of interesting other applications that we haven't really gotten to or to explore fully. And so these citations are actually research from other labs where they've used the Rico data set to improve accessibility, understand material design adoption, model brand perception on Android apps, and also train generative models of design. So yes, there are many other applications that can use this data set, but I'm happy to chat more about them. So I want to change gears a little bit. We talked about kind of what approach to data-driven design that's different from A/B testing. The second approach I want to talk about is something that I'm going to call using experimentation engines. And the domain that I'm going to use to motivate this work is actually fashion. And so I don't know how many fashionistas are in the room here, but apparel is actually a $3 trillion global market, and so it actually dwarfs the automotive industry, advertising, consumer media, and mobile phones combined. So it's a huge market, but it's really interesting because the way we shop has been relatively unchanged for a long time, right? Everyone's used to these kind of e-commerce screens where you like search for things and get hundreds of results back these days. Certainly, one player in this space that's kind of trying to disrupt this is Stitch Fix. How many people have heard of this company? Okay, so a few people. Basically, it's a subscription-based model where they send you boxes of clothing. Every month, you get to keep what you want and send things back. You pay $10 a month, basically, for this service. But that means you don't have to like search through, hundreds of things online. There's a personal stylist kind of handling all this stuff for you. Now, their claim is that the personal stylist is using data-driven interfaces to actually be able to help all of these people instead of only helping a few people. So they're really, it's because of, let's say, machine learning interfaces that people are able to really scale the personal style advice that they're giving. So what my group is really curious about is what if we can remove this like middleman and directly expose to you these AI-driven personal stylist bots. So that's what we're working on. Now, the interesting thing, though, is if you set out to build something like this, it's actually a little intimidating because the number of like fashion activities out there are a lot of them. It's numerous, right? And then there's all of this great work being done in computer vision and natural language processing about like outfit compatibility, how to parse people and their clothing from images. So there's a lot of models you can build to kind of support all of these different activities. On top of it, there's all of these data sources. So you kind of have this explosion, and you're really left wondering where are the right choices in this space, because if you actually look on the App Store, there's, I don't know, like 50 wardrobe apps that have never taken off. Like, how many people use a wardrobe app? Right, like, so, building one of these apps is a lot of work, but if you're gonna spend all of this time building something, you might as well build the right thing. And so what we felt was there was this need for what I'm gonna call an experimentation engine. And it's something that can support basically the whole design process, including need finding. And initially, what it helps you do is it helps you need find and ideate through a Wizard of Oz system, and that's just a fancy way of saying you have humans doing the AI work for you. And then you kind of get to stage automation. So once you figure it out, like what interactions you want to support and how to support them, you can actually slowly deploy an automated solution. But what you get to do is be in a tight feedback loop with the user so you can iterate very quickly. So chatbots are actually a great way to do this. So that's the instantiation of the experimentation engine that we used. And so we built a Facebook Messenger bot that basically connects users to one-on-one sessions with the stylist initially. So this is how we initially Wizard of Oz the system so that we can do need finding. We released the bot for 3 weeks, and this is actually, I was surprised by this, so I highly recommend this to other researchers, which is like, just put out some ads on Facebook or Instagram if you're doing something like this, and you'll actually get organic users, right? You'll find people who, we found people who were actually looking for free fashion advice. And, we got 88 users in 3 weeks, which I was surprised by. And we, we basically had we recorded the styling conversations that they had with the bot. Through this process, we were able to identify 3 common fashion problems. And so people really care about style and context. So when people talk about problems, they use this higher level language. So they want to know what's appropriate for different contexts, like what's appropriate for a wedding, what's appropriate for work. They also want to look, professional without looking boring. So they're using these higher level, terms or to describe their requirements. They also had questions about compatibility. So, things like what matches with gray slacks. This is a more detailed one about how do you pair skinny pants with ankle boots. But this wasn't the norm. And then finally, it was interesting because a lot of the users also just did basic product search. So they were just like typing in keywords like they would to a search engine. And so it was curious that they would just type it into a chatbot rather than Amazon, right? And so this kind of also, I think, indicates that people are overwhelmed with the number of choices they have when they type in rain jacket into Amazon. And so, it was also interesting because we also got to see how the humans or the stylists were responding to the users in order to kind of answer their questions. And so the most common interaction pattern that we really kind of took to heart was that people use this multimodal response style all of the time. So they wouldn't just recommend, items. They would show items, but then they would always explain them with text. And that's kind of what you could say is missing from most search engines or recommendation engines, right? They just show you things, but they never tell you why that matches your query. And so that kind of became the goal, is like we said, like, can we get close to this type of interaction? What would it take? And so what we ended up doing is we trained a multimodal regressor that maps images from a pre-trained visual embedding to 2,500 text concepts. So the reason, there's a few things going on here. First, we wanted a model that supports multimodal interaction. So you can input images, you can input text. But we also wanted something that would output multimodal stuff. So a lot of work has focused on multimodal input, but not multimodal output. And we wanted both, because as I said, we wanted to show people products as well as explain why they satisfied the requirements. Now there's this little detail here that I'm mostly going to gloss over, and that's the fact that we trained from a pre-trained visual embedding. And it's interesting because prior work here has actually done training with what they call joint training. So they were basically learning a visual space and a language space, or a space over words at the same time. But what ends up happening is when you collect data, so we were collecting data from product pages. When you collect the images and the text, so the copy associated with an image, what you find is that the text is actually often incomplete. And by incomplete, what I mean is they don't actually have all the labels that one could apply to this pair of genes. And so, and that's because this is marketing, speak. And so the person who wrote this copy has a certain point of view and wants to express that. They're not trying to tag this image with every possible keyword that could be related to it. And so this is what makes the text space actually kind of incomplete and the visual space more complete, because in some sense, the pixels represent all of the styles one could represent visually. So what we found was that there's kind of this information imbalance between the visual domain and the textual domain. And so if you really care about this, I actually recommend training first a vision embedding separately, and then using kind of just a basic regression method to learn the text space from the pre-trained embedding, visual embedding, to get the best results. And that's a little kind of tangential, but I think it's an important point. The other thing we had to do to generate explanations is we also, again, had to create a lexicon over fashion concepts. One isn't readily available. Just like we had to do this for UX concepts, we had to do this for the space of fashion. The thing we did was we actually organized this vocabulary into 8 categories, and I'll show you in a second why this is useful. But basically, we could do queries now where we could query with words like, striped, and get back things that have striped patterns. We could do things like query with the word maxi and get back dresses as well as skirts, because maxi is a silhouette that applies to both types of clothing. We could also do higher level stuff like styles. So you can see biker means leather, black leather jackets. And the interesting thing is in this space, we want to basically generate explanations, because this is how people are going to be querying. They will be like, I want to have smart workwear, right? So you'll show them some results, but now you have to explain why this is smart workwear. So that's kind of the task we have before us. And the reason it's useful to kind of have these other categories is basically we're going to draw from these other categories to generate the explanation. So our first strategy right now for generating these explanations is to look at highly correlated concepts in the other category domains of fashion and kind of do a Mad Lib style approach for completing these explanation templates. So if someone queried with urban activewear, we can show kind of the results for it, and then this is automatically getting generated. And basically, we're filling in the things you see in bold based on the category that they belong to. So it's like basically like Mad Libs. Does this make sense? Okay. So we, I'm going to skip over these details, but basically what we found was that we did a user study, and we found that 94% of the time people felt like the descriptions actually were explaining the results, which is good. Obviously, I think we can improve our method of generation here, but this was kind of our first attempt at generating these kind of whys. And now, kind of looping back to the experimentation engine framework, what I'd like to say is, now that we have this model, what we want to do is actually go back and deploy this and see if we can actually answer people's questions with results, visual results, as well as explanations, and see how well they respond to it. So that's the next step that we're just getting to. But to finish off, I just want to show you other kind of like applications that we can reuse the same model for. So it's not just for keyword-based queries. You can also do things like find the same look for less. So since we understand styles, we also understand brands, like what makes a brand the way it is. So Zimmerman is a brand, expensive brand. So they sell dresses for more than $1,000. You might want to achieve that same look, but pay less. And so, we can identify other brands that basically have a similar style, and we say, well, it's the same bohemian style with, florals and tiered ruffles. It's ideal for breezy beach days. Similarly, for Burberry, you can, they're known for their trench coats, and so we also found other kind of double-breasted, clean style trench coats by these other brands, and they cost less than $1,000. So the other thing is you can actually hook up this architecture to other models to do things like outfit compatibility. And so I'm going to kind of gloss over this, but basically you can do things like generate capsule wardrobes. So how many of you know what a capsule wardrobe is? Okay, it's a okay, one person. It's a phenomenon in fashion right now that's trending, where you basically maximize the number of outfits you can create, but minimize the actual number of items, so you can kind of like reduce your wardrobe, but still have like maximal versatility. And usually, when you see people create these capsule wardrobes, I have to admit they all look black and gray. And so one thing we were hoping for is we can actually produce some more diverse looking capsule wardrobes, and indeed we can for, like, let's say a tropical summer wardrobe. And again, we can kind of generate similar like explanations about like why these are good outfits or why these are good capsule wardrobes. And then the final application that I want to kind of show you with this data is that how many of you look at fashion magazines? Okay, cool. If if you look at them, you might realize that a lot of them are actually pages filled with just curated objects that belong to a certain like catchy style. So they usually combine some style word with some like type of clothing or another style word that wouldn't normally go together and things like that. So what we are trying to do is see if we can do like a data-driven fashion magazine where every week, since we're crawling this product data continuously, every week we can pull out the themes that are going on. So like between November 15th to 30th, one concept was expert menswear. I don't know what that means exactly, but that's what the model is suggesting. Sparkling dresses, a bit more straightforward. Another one was, at the end of December, was crafted hoodie. So these are kind of like fun applications still in progress, but I thought I would tease you with a few of these examples. Given the time, I'm going to stop here, but I'm happy to take any questions.
So I think we probably just have time for one or two quick questions, but Ranjitha will be here afterwards if anyone wants to come up and speak with her as well. Any questions?
Yeah.
User flows in UI, Android UI mapping.
Yeah.
So how did you handle loops?
How did we handle loops?
For example, a lot of times I search something, go back, search.
Right.
I
Those
keep
would.
searching through all the.
Those would be really long traces. So there's nothing we're doing right now that tells us we're back at some state we've visited before. So those would be kind of like outliers in that flow visualization diagram where it would just be a very long trace if you just kept, searching and searching.
So do you like break them down and then put them back into the flow, or do you retain that loop as a flow? Because I can imagine some UIs inherently leading me to loops.
Yes.
But then I would end up taking the shortest flow. But to get to that shortest flow, I might have to traverse some multiple.
Right. And no, right now, I mean, I definitely think there's a lot of room for improvement in that visualization. We don't, we basically line up and merge nodes where people have roughly done the same thing at the same time. So if you have people kind of going back to a particular state, that will just be a very long trace right now. But yeah, we'll basically indicate that it's an outlier where the person was very confused. Because, normally if you know what you're doing, it wouldn't take you that long to complete something. Yeah. Yeah.
I was interested when you talked about design interactions.
Mm-hmm.
And when you map through the flows, wondering if you looked at sort of guessing what the intent the user would be trying to get to when you were trying to map through the flow. Like how do you aggregate different design interactions into like a pattern and they're trying to get to this or something?
Yeah, so I think there's kind of two strategies we're looking at. One is, again, using the semantic classifiers. I didn't kind of complete that loop, but what we're doing now is actually using those flow classifiers to go back and kind of chunk up a long trace into like, okay, in this period they were doing search, in this period they were doing checkout, things like that. I mean, I guess if you're going in a loop, then that would be easier to see if we could chunk things into these higher level abstractions. Yeah, so I think that's definitely the next step. And then we want to come back and say, well, are there definitely patterns with which people design these search flows or checkout flows? If so, if there are patterns, can we say which pattern performs the best? So we're kind of like still 2 steps away from completing that entire loop. But yeah, great question.
All right, let's thank